taking advantage of this for part of her thesis. And so she's going to give you an update. You should treat this like an ongoing project, so please fill out life forms. She's not done with this yet, and so feedback would be very useful.
All right. Hi, everyone. My name is Stephanie Strong. I'm one of Eric's master students at USM. And like Eric said, the past couple of months, I have been doing some data analysis on some of the raw data from the Pursuit survey. So the survey was completed in September of last year. A total of 117 tows were conducted in over 50 stations on the continental shelf from Ocean City, Maryland to around Hudson Canyon. Two dredge tows were completed for each site, one for surfclams and one for ocean quahogs with different bar spacing, the larger bar spacing for Atlantic surfclams. And then each species on the boat was sorted into size classes from 30 to 200 millimeter in 10 millimeter increments. This graph you saw briefly in the Stobo presentation. I'll go over it a little more in detail. So the pink boxes, all the boxes are sample sites from the survey. The pink boxes are stations where out of every 25 total clams caught, more than 24 of them were surf clams, so a vast majority surf clams. In contrast, the green boxes are sites where out of every 25 total clams, more than 24 were ocean quahogs. The yellow and brown boxes are sites where there was an overlap between the two species. Yellow boxes are where the majority caught were surf clams, but between 1 and 12 of every 25 total clams was an ocean quahog. And then for the brown boxes, out of every 25 total clams, the majority were ocean quahogs, but between 1 and 12 were surf clams. And so this region of overlap is extending from about 40 meters to 55, 60 meter depth. So for all of the data that they compiled during the cruise, I separated the data into tows and then species for each tow. 89 tows contained Atlantic surfclams, while 99 tows contained ocean quahogs. And so for each species of each tow, I calculated the mean, median, range, 25th and 75th percentiles, interquartile range, minimum and maximum size. And then I also supplemented my data set with environmental variables, depth, temperature, which came from the ROMS-Doppio data set, and I used a mean monthly temperature for September between 2016 and 2020. Added LPUE, the distance of the tow, the latitude and longitude of the station, and the dredge type. Tows on the survey were indicated with either P or S. P was the surf clam dredge, S was the quahog dredge. And then also the density of each species for each station. So I have a few plots here. In all of the plots, the light blue bars are going to be surf clams. The dark blue, kind of looks a little bit black, will be quahogs. So I separated all of the stations into depth intervals of 2 meters. And then after about 45, 50 meters, I did 5 meter intervals because there were a few number of tows in the deeper sites. And then I outlined the region of overlap in red. So as you can see, you go from surf clam dominated in shallower waters to quahog dominated in deeper waters. And within that overlap region, you really transition from high surf clam density to high quahog density. So this further indicates that this is the region of depth that we need to be looking at. This is maximum size for both species at depth, and again, I indicated the region of overlap in red. The maximum size for quahogs did not vary much over the depth range, whereas the maximum size for surf clams decreased from about 160 millimeters to about 120 millimeters, going from about 40 meters to 55 meter depth. And then the same is true for mean size, where the ocean quahog mean size did not vary much, but the Atlantic surfclam mean size decreased from about 130 meters to about 190 meters over the 40 to 55 meter overlap range. Yes, foot meters, sorry. I then took the temperature and divided that into intervals of 1/4 of a degree and then 1/2 a degree at the warmer temperatures because there were very few tows in the warmer temperatures. The density of surfclams varied a little bit, but not too much. The higher temperatures, 14 to 15 degrees, is still well within the thermal range for surfclams. However, the maximum thermal temperature for ocean quahogs is about 15 to 16 degrees. So the density decreases as you get warmer. The high densities of ocean quahogs are found at the cooler temperatures where surfclams don't normally reside. The exception here is that 15-degree temperature of high quahog density, and that was only because there were 3 tows within that interval for ocean quahogs. So while Atlantic surfclam density did not vary much over temperature, the size did. And the opposite is true for quahogs. While quahog density varied, their size did not. So as temperatures get warmer, the average size of Atlantic surfclams increased from about 100 millimeters to about 140 millimeters. So this indicates that there are very large adult individuals at higher temperatures, which is what we would expect to see given their range shift, where recruits are not able to survive at warmer temperatures. So any individuals caught in regions of high temperature inshore tend to be adult animals. And then mean size by latitude. The latitude of this survey was only about 2 degrees. So I grouped each tow into 1/4 of a degree latitude intervals. So we may not see the entire picture here, given that the range of both species vastly extends beyond the survey range. However, the mean size in surfclams did not vary much between the latitude range. However, the ocean quahog size did increase as you moved into higher latitudes. And again, this is what we would expect to see because the range of ocean quahogs extends further north than the range of Atlantic surfclams. I then looked at the significance of the dredge. And again, just for clarification, the P dredge is the surfclam dredge with the larger bar spacing. The S dredge is the quahog dredge with the smaller bar spacing. Both the minimum size and the 25th percentile for both species was lowest in the S dredge, which means that the smallest animals were caught using the quahog dredge. The interquartile range was largest for both species, also in the quahog dredge, so the largest range of sizes was also caught in the quahog dredge. In my statistical analysis, the dredge type was only significant in 2 out of, I think, 11 different ANOVAs that I ran, and for each species, so 22 total. It was only significant in the range for Atlantic surfclams and the interquartile range for ocean quahogs. So in conclusion, the 40 to 55 meter depth range is where this overlap between Atlantic surfclams and ocean quahogs is occurring. Right now, the quahog size remains relatively constant over that range, while the surfclam size is decreasing about 40 millimeters in maximum size and 30 millimeters in mean size from 40 to 60 meters in depth. And in the mean density graph, the transition from high surfclam density in shallower waters to high quahog density in deeper waters. When you get to that 40 to 60 meter depth range, you can see the shift in density. The surfclam density remains constant across the temperature, whereas quahog density decreases as temperatures get warmer because quahogs are not able to survive in about 15 to 16-degree temperatures. The surfclam size increases with temperature, which is indicative of older animals at warmer sites because of a differential survival in recruits. Surfclams are recruiting in warmer waters, but the recruits just aren't surviving. That is it. Are there any questions?
We got time for some questions of